If you thought the network world was without conflict, think again. In the realm of technology, there has always been a battle between applications and those who support them and those who create them, and the network people. Here's how it goes. The application isn't functioning, the application folks can't figure it out, and they say, this can't be an application problem, it must be something network related. The network guys, on the other hand, troubleshoot the application. They go, I don't know anything about your application, but I know I can reach from here to here. I can ping it is the end of the argument. So it must not be the network. And they go back and forth and back and forth. And in the end, both sides are usually right and both sides are usually wrong. Who wins most battles? Well, it depends on how good each side really is. Here's the application layers of the OSI model and the TCP/IP model. You can see that TCP/IP was so flippant that they said, I'm going to group 3 layers of the OSI model into one big ol' application layer. And in Jeremy's opinion, they were actually right to do that. That's because when we're communicating across the network, these 3 layers typically happen before we even think about anything network related. Here's what I mean. Let's say that we have a computer and it's a checkout register at a local convenience store, right? It rings people up. And when somebody goes on here and says, I want to buy what are those things called that my kid has, those spinners, the fidget spinners, the things that spin around and keep kids with ADD just spinning. So somebody wants to buy one of those little fidget spinners. They come up to the cash register and say, I'll take one of these. It happens to be $5. So the cashier types that in and it's going to store that purchase over here on the convenience store server. Here's how the network communication begins at these 3 application layers. First thing is the application layer itself, the one at the very top. This is the layer that houses the network-aware application. That is, the application that is going to be doing the communication across the network sits there. Now, this isn't all applications, like if you're playing solitaire on a computer, that's probably not network-aware. It's designed for just you, right? So if it's a network-aware application and it says, I'm going to initiate or receive that network communication, it belongs at the application layer. Now, inside of that application, it then moves it down a layer to the presentation layer and formats it in a flavor, I guess you could say, that is compatible with the other side. What do you mean by flavor, Jeremy? Well, here's what I mean. If these two are speaking different languages, then they're not going to be able to communicate, right? If I'm speaking English, this guy's Spanish, it doesn't work. So the applications, and I'm talking the applications themselves, I'm not even talking about protocols at all at this point, I'm talking about the applications, have to speak in such a way that's understood by both sides. So at the presentation layer, you end up having formats, things like HTML, things like JPEG, things like MP3, and we could go down the list. These should feel somewhat familiar if you're familiar with computers, because these are common formats. A server probably understands those, and the application running on this computer probably understands those. Now, it doesn't mean that it has to be a standards-based format. I mean, maybe the cash register software that is created for this device uses a proprietary coding. That's fine, as long as the server supports that proprietary coding and can understand it when it goes across. Ooh, one other thing that's really interesting to find out here, this is often where things like encryption happens. And what freaks people out about that is when I mention, oh, it's generic encryption. Don't worry, it's good. Huh? How is generic encryption good? Well, people found out a long time ago the only way to make a really good security standard is to make it open source. That is, here's how we do the encryption. Here's the formulas we use. Everybody look at this, try and make it better, and I bet at the end of the day, knowing the formulas, you still can't break it. That's good encryption, right? That's somebody that knows how it works. It knows how it's being calculated, but it's so complex or so, it takes so much work to break through that everybody's like, I surrender. I'm not gonna try and break that encryption. So that's when we're talking about, for instance, encryption across the internet. It's generic encryption, but it's really good. SSL and a lot of the encryption standards that come with it are open source and understood by all servers. Thus, it exists at the presentation layer. The last thing the application will do is manage the session with the server on the other side. Now, I would suppose at the point that you walk up with that little fidget spinner for $5, it already has a session going. And what I mean by that is it's got some communication started. It's authenticated to the server, or it's opened a connection that says, hey, we're valid to exchange communication over a session, right? All of those three things, those three layers, the application, which knows to communicate across the network, the formatting of that data in a way that can be understood by both sides, and the start and stop and maintenance of the session between those, that all happens within the application, which is why TCP/IP, when they created that model, decided we are going to group that communication all into one big application layer. The transport layer is where we as network engineers really get involved. And that's the next video. I hope this has been informative for you, and I'd like to thank you for viewing.